Hello, class. In this lesson 2.4, division, you're going to learn how to divide polynomial using one of two methods, either long or synthetic division. So let's start with long division. To use long division, we're going to start by setting up our problem using the long division setup, which, if you remember from elementary school, simply is your division box with your divider inside, dividend inside here, and your divisor of x minus 2 on the outside. Now, to divide polynomials using this technique, we focus only with the leading term of both the divisor and the dividend. So here, we're asking ourselves, how many times can x go into x to the third power, which is equivalent to dividing x squared by x, which is going to be x cubed by x, which is x to the second power. Now, since this is x to the second power, we line it up again to the same power in the dividend. And the reason for that is because when we move along, we want to reach again the end. And when we get to the constant, we know that we're done dividing using this technique. Now, from this point on, what we do next is that we multiply our quotient with our divisor. Again, same procedure as long division. So this is x to the third minus 2x to the second power. And we're going to subtract in our final step. So right here, we are going to subtract this quantity here from the two terms above it. And then you'll see again that the like terms are lined up perfectly. Now, to subtract this, it's probably better just to simply switch the sign since we're subtracting. It's the equivalency of switching the signs to these two terms down here, and then just simply following your addition rules for integers. So right here, combining a positive one with a negative one, that's equal to 0. So this cancels out. And combining a positive 4 with a positive 2, that adds up to 6. Bringing everything down from the right of that, we end up now with a shorter polynomial. Then we just simply follow the procedure and do the same 3 steps over again. So how many times can x go into 6x squared? We'll divide it out. 6x squared divided by x is equal to 6x. And now multiplying 6x with x minus 2, that's 6x squared minus 12x. Changing the signs and combining the terms, this becomes 0. This adds up to negative 4x, and we can bring down the 8. We do this one more time. So how many times can x go into negative 4x? So divide negative 4x by x, and that's negative 4. The answer to that is negative 4. And again, the same procedure. Multiply negative 4 with x minus 2. That's going to be negative 4x. Negative 4x plus 8. Switch the sign. So make the negative 4 into a positive 4. Make the positive 8 to a negative 8. That's the equivalency of subtracting. And then adding these numbers, this adds up to 0. This adds up to 0. And that's going to be your remainder. Your remainder is 0. Now our solution here then is simply going to be, again, this up here. There's our quotient. So x to the second power plus 6x minus 4. There you go. Let's do another example again. So it's all about repetition and doing the same steps over and over again. So on this example here, to use long division, we're going to, again, get 2x plus 7 on the outside, my divisor, and on the inside is 2x to the third power plus 5x to the second minus 19x minus 42. Now, with with the first terms on each one, on the divider and dividend and divisor, we ask ourselves, how many times can 2x go into 2x to the third? So we just simply do that division, which is going to be an answer of x to the second. Now multiplying this with our divisor, we end up with 2x to the third plus 7x squared. Since we have to subtract, switching the signs to these two terms in the bottom, and adding is the equivalency of subtracting. So switching the sign and adding will be our subtraction operation. So this becomes 0, and this becomes negative 2x squared. Bringing down the negative 19x and the negative 42, we repeat the process. So now how many times can 2x go into negative 2x to the second power? And the answer to that is negative 1x times, so negative x. Multiply our negative x with x squared, 2x plus 7. That's going to be negative 2x to the second power minus 7x. Switch our signs and combine the terms going down. We end up with 0. This ends up becoming negative 12x, and we bring down the negative 42. So now, again, we repeat the process one more time. How many times can can positive 2 go into this negative 12x? So divide it out, and the answer to that is negative 6. So multiplying negative 6 with our divisor, we end up with negative 12x and negative 42. Switching our signs, this adds up now to 0, this adds up to 0, and again we get another situation where our remainder is 0. So our quotient is here. It's x squared minus x minus 6. There's our answer. All right, moving along, let's look at an example now when our remainder is not going to be 0. So using again the same procedure of x plus 1 on the inside and 3x to the third plus 7x squared plus 2x plus 3. So our remainder is not going to be 0, and we're going to discuss how we write our answer when we have a non-zero remainder. So just practicing again our procedure. 3x to the third power divided by x is 3x to the second power. So that lines up above the 7x squared. Multiply plus 3x squared and subtract. This becomes 0. This is 4x to the second power plus 2x plus 3. And now we start again. So now 4x squared gets divided by x, and that's going to be 4x. Multiplying 4x with x plus 1, that's going to become this. Let's switch the signs so we can subtract. That becomes 0. And 2 minus 4, that's negative 2. And bring down the 3. So now negative 2x gets divided by x, which is negative 2. So multiply. Switch the signs. Again, this cancels out to 0, but this time our remainder is 5. 3 plus 2 adds up to 5. And because we end up with the remainder, this is how we write our solution. So we still have this part here, our solution, but we are remaining to divide 5 by our x plus 1. So that's what we do. We simply add that part to our quotient. So our quotient is 3x squared plus 4x minus 2. And since we still have remaining the 5 to divide by x plus 1, we simply say we have 5 that needs to be divided by x plus 1. So this is how we write our solution when we have a remainder that is not 0. So let's practice this again. So here again, on this example, we have our divisor is now a trinomial of second degree. So we have a quadratic divisor, and we have x to the fourth minus 5x to the third plus x squared plus 20x minus 10. So just like before, again, only focus on the first term of each, the dividend and divisor. And how many times can x squared go into this x to the fourth power? So divide that out to get your answer, which is x to the second. So that's going to go right there again. Line it up. Make sure that you line it up to the correct power. If you put it in the wrong place, then you might accidentally get to the end prematurely, and you will have to divide one time and you miss that, or you end up dividing too many times, and again you still end up with the wrong answer. So you want to make sure that you line this up so you know, okay, I have to basically do it maybe 1-2 more times. So let's multiply now this x squared with x squared minus x minus 5. So that's going to become x to the fourth minus x to the third minus 5x to the second power. Since we need to subtract, we can just simply switch the sign to these three terms there and then add, and that'll be the equivalency of subtracting. So this becomes 0, adding a negative 5 and a positive 1, that's equal to a negative 4. Adding a positive 1 with a positive 5, that's equal to 6. And then bringing down the other terms, we end up with this. So now our first term of negative x to the third power gets divided by x squared, and that's negative 4x to the power of 1. So multiplying negative 4x with these three terms, we end up with negative 4x to the third, positive 4x to the second, and a positive 20x. Switch the signs. Here, this becomes negative, and then follow our addition rules of adding positive and negative numbers. Here, a positive 4 and a negative 4 added together becomes 0. Adding a positive 6 with a negative 6, we subtract that, so that becomes a negative 2. And this becomes 0. Adding a positive 20 and a negative 20, that becomes 0. So plus 0x. And then the minus 10. And then again, now our first term is now the negative 2x squared. So how many times can x squared go into negative 2x squared? So divide it out to get that answer, and that answer is going to be negative 2. So now multiplying negative 2 with our trinomial, we have negative 2x to the second power, positive 2x to the first power, and positive 10. Switching our signs, this becomes positive, this becomes negative, this becomes negative as well. We can combine our like terms. This adds up to 0. This is going to add up to negative 2x, and this adds up to negative 20. So we have a remainder here of 2 terms, but it's done the exact same way. So our answer is x to the second power minus 4x minus 2. But since we have a non-zero remainder, we're going to add this negative 2x minus 20 over our divisor, because that's what having a remainder means. It means that we're remaining to divide that last part there. So there's our solution. Now, the last examples, again, are examples where we're missing a power. Notice that on the previous example, in this last, I'll do example number 3. Notice in example number 3, we have x to the third, x to the second, x to the first, and then our constant, which is essentially x to the 0 power. If we're missing a power, we need to use the number 0, 0 as a placeholder for that missing power. Like right here in this example, we have x to the fourth power, and then x to the second, x to the first, and then our constant, which again is x to the 0 power. So we have all the powers from 4 to 0, with the exception of x to the third power. We have no x to the third power. So what we do on that one is that we use a 0x to the third power as a placeholder for that missing power in the polynomial. Because we have to have every single power accounted for, because again, if we have a quotient, we need to line it up so it could combine when we subtract, and we know also in our quotient, we know exactly where to stop. So let me just move this down a little bit, right here, okay? And we have x minus 8 on the outside. So as before, we start with the first term, and we get x to the third power. So you see, we need to have that x to the third power there, because if not, then I won't be able to write this above anything. It won't line up with the x to the second, and obviously not x to the fourth. So we need this to be there. So we line up that quotient above that appropriate power in our dividend. Now multiplying, we end up with x to the fourth minus 8x to the third. Let's switch the signs. This becomes 0, and this is 8x to the third minus 64x squared plus 9x minus 8. Now 8x divided by x, that's 8x to the second power, positive 8x to the second power multiplying, that's 8x to the third minus 64x squared. Let's switch the signs. This becomes 0, this becomes 0, and since the leader numbers are 0, we can ignore that, and we can now start off at 9. So 9x minus 81. So this is now the leading number. This right here is 0, this is 0, so we can ignore that. And the starting number is now 9. So how many times can x go into 9x? Well, that answer is 9. And because it's a constant, that's going to go above the 80. Again, power of 0. X to the 0 power has to go above x to the 0 power. That way I know that I have reached the end. So after multiplying and subtracting, the number I should get at the end is my remainder. Well, the number I get at the end is my remainder. So 9 times x, that's 9x, and 9 times 8 is negative 72. Switching our signs, this cancels out, and this is going to end up to 8. So there is my remainder. So our solution here is x to the third power plus 8x to the second plus 9, and our remainder of 8 over x minus 8. Now, for example, number 6, here we're missing the power of x to the first power. Notice we have x to the third, we go to second, and we jump to our constant, which is again technically x to the 0 power. So we're missing x to the first. So 12x to the third divided by x, that's 12x to the second. So 12x to the third, and multiplying 12x with 1, that's going to be 12x to the second. Switch the signs. This is 0, and this is negative 8x to the second. Plus 0x plus 4. And now, how many times can x go into negative x squared? Well, the answer to that is negative x times. Negative 8x times. Multiplying, and now switching our signs. This again adds up to 0. This is now 8x plus 4, bringing down the plus 4. We do this one more time, and 8x divided by x is 8. So 8x plus 8. Switch our signs. This is 0, and this is negative 4. So our solution is 12x to the second minus 8x plus 8 plus our remainder of negative 4 over x plus 1. Now, for this particular problem, because we have a negative 4, there's another way of writing this answer. Instead of adding that negative 4, we can also just write the equivalent value of that, which is the same thing as subtracting a positive 4. So it would be, again, this. Either notation is correct, and there is no preferable way of writing it, but both of them are correct. Now, having gone over these 6 examples and using this technique, there is a shortcut called synthetic division. Now, synthetic division is a shortcut method to using and dividing polynomials. However, this method, again, does have a catch. This only works if my divisor, what I'm dividing by, is a binomial, 2 terms, where the coefficient, the leading coefficient specifically, is 1. So in other words, I have to be dividing by something that looks like this, x minus k, where k is going to be some positive or negative number. If I'm dividing by, again, my divisor is written like this, I can use this synthetic division, where I start off by bringing down the first number and then simply multiplying this number with this value of k, with this number that I'm subtracting, and then adding the term going downwards, where the values of a, b, and c are going to be the coefficients of my dividend right there. So I then multiply and then add, multiply this answer with k, and then add these 2 values, multiply this answer with k, and then add these 2 values, and till I get to the very end, where the numbers I get here are the coefficients of my quotient, and the last number here is going to be my remainder. So for example, look, on this example, because my divisor is in this format, this x minus k, I can use this shortcut, this synthetic division notation. So I write my division box upside down, and what I'm going to do is just simply use the coefficients of my divisor, which are 1, negative 27, and negative 28. So 1, negative 1, negative 27, and negative 28. The number that I'm subtracting here is a negative 4, because x plus 4 is the same thing as x minus negative 4. So the number I'm subtracting is negative 4. So in other words, you're simply getting the opposite of this number right here. So if it's plus 4, you write negative 4 out there. Now here's the procedure for synthetic division. We start by bringing down the first number down, and then we simply multiply this number with this number out there. So that's negative 4. We add, and because the 2 numbers are the same signs, that's going to be negative 5. We again multiply to get positive 20, negative 5 again multiplied with negative 5 multiplied with negative 4 is positive 20, and again we add negative 7. Multiply 28, we add, we end up with 0. So here, using synthetic division, we end up with a remainder of 0. So our solution, our quotient, is going to be these terms here, where these are the coefficients to our quotient. Now, since we started off and we're dividing an x to the third power by an x to the first power, our quotient is always going to be 1 degree lower than our dividend. So we have x to the second, x to the first, and our constant, which is x to the 0 power. So here's our answer. It's going to be 1x to the second minus 5x to the first minus 7. So if our divisor was to the fourth power, our answer would start off with x to the third, x to the second, x to the first, and then so on until we get to the remainder, the constant and then the remainder. So let's do another one of those. All right, so look right here, we have another situation where we can use synthetic division. Again, be able to recognize that we can use synthetic division is going to be important, so we don't have to use the long method. But again, this technique only works 22. This technique only works if our divisor is written again like this, as x minus k. So right here, what I'm subtracting is a positive 2, so that goes right there. Again, the opposite basically of that number there. And the procedure is real simple. Bring down the 3, multiply, and then add. Since the number is a negative and a positive, well, the rules again for adding a negative and a positive is to subtract the number. So negative 18. Multiply, negative 30. No, sorry, 14. This is 14. Sorry, I had a brain fart there. That's negative 16. Negative 16, which when I multiply by 2 is going to be negative 32. Adding a positive and negative 32, that's going to be 5. And then that becomes 10. And adding a negative 10 with a positive 10, that's 0. So my answer is 3x to the second power minus 16x to the first power plus my constant of 5. And again, there's no remainder, so I don't have to add the 0. Now, if my remainder is not 0, then I just simply add that. Again, first recognize that you can use synthetic division. Again, here we have x plus 5, so I can use synthetic division. So I put negative 5, that's what I'm subtracting from the x. I'm subtracting a negative 5 since it's positive 5. I have 1, 1, negative 22, and negative 1. So multiply, add, multiply, add, multiply, add. So here is my remainder, and my answer is 1x to the second power minus 4x to the first power minus 2, and then plus my remainder of 9 over x plus 5. And like I said, this is a shortcut, but unfortunately it doesn't work with every example. From the first 6 problems, it would only work with a couple of those, or actually maybe half of those. Not on all of them, not with all of them. Because if we're missing like or let's do another non-zero remainder. So this right here, we have 3, 4, negative 16, 20, and negative 16. This would be 12, negative 4, multiply, add, multiply, which is 8. And our answer is 4x to the second power minus 4x to the first power plus 8. And this last one is our remainder. So plus another 8, however, over x minus 3, since that's our remainder. Now, if we're missing a power, like here, we just do the exact same thing. Use 0 as a placeholder for that power. So notice that we have x to the third power, and we're missing x to the second because we skipped to x to the first and our constant x to the 0. So we're missing this x to the second power. So we're going to write the number 1. Since x to the second power is missing, we're going to write a 0 for that, and then negative 49, and then the constant 120. We're adding 8, so we write a negative 8 there because this is the equivalency of subtracting a negative 8. Bring down the 1, multiply, add, multiply, add, that's 15. Let's multiply. That is negative 120. And adding, again, gives us 0. So this one doesn't have a remainder, and we end up with x squared minus 8x plus 15. And then, again, one last one. Here, we're missing 2 powers here. Notice that we start off with 4. We go to 3, but we're missing the second power, and we're missing our first power because this is our constant. Our constant is x to the 0 power. So we're going to have to put 0 in 2 locations. So we have 1 negative 9. We're missing the power of 2, our linear power, and then our constant is negative 1. Put a positive 9 on the outside, multiply, that is 9, add, multiply, add, multiply, add, multiply, add. So our last number is our remainder. So our solution here is x to the third power, because again, we start off with the fourth. So this is going to be x to the third power plus 0x to the second plus 0x to the first plus our constant of 0 and then our remainder. So plus 1 over x minus 9. But of course, because these are 0, we don't have to write those, and we could just simply jump to the last one. So x to the third power plus negative 1 over x minus 9, or x to the third power minus 1 over x minus 9. So that is our solution. So there, this is how you use long division or synthetic division to divide polynomials. Hopefully, again, you found this easy to follow, but if you do have any questions, again, do not hesitate to send me an email or a message on Remind. And again, thank you for watching, and I hope you have a great day.